So the next three learning targets, 6, 7, and 8, are all about ellipses. Okay? A circle is just a special type of ellipse, really. So we're going to talk about ellipses as we're going to do the same kind of stuff we did with circles. We're going to be able to graph them. We're going to be able to write the equations for them. We're going to be able to rewrite general form to standard form. All those things are going to come back again very similar. Okay? All right. So here's the deal. An ellipse, this is a fancy definition, okay? It's really just an oval, okay? An ellipse is defined as a set of points, P, for which the sum of the distances from two fixed points, called the foci, is constant. So this is what that means. I'm going to show you, like, this makes sense. You're going to make an oval, all right? There's going to be a center to the oval, and there's going to be these two fixed points. I can change where those are depending on how wide and stuff I want it to be. There's these two fixed points. Right now it's telling you the distance from fixed point 1 to P is 5 units. Okay, that makes sense. 1, 2, 3, 4, 5 units. Okay? The distance from the second focus to P is just 1 unit. And so the sum of those distances is 6. Correct? All right, so what I'm going to do is I'm going to animate this, and P is going to start moving to like draw the oval. And it's going to start showing you the distances from each focus to that point as it's moving. And that 6 is going to stay the exact same. Okay? That's what's happening. So the sum of the distances from each fixed point to the point on the oval, the sum of those two distances is always going to be the same every single time. I can change where this point is. I can do a vertical one. It's super long. But again, that 9.98 is going to stay the same the entire time. Okay, that's the fancy definition for an ellipse. That is why later in this section, when you're saying to me, why are those foci points important? Because we're not graphing them, blah, blah, blah. If you didn't have them, you wouldn't have a definition of ellipse. You wouldn't have anything to base the whole oval on. Okay, that's why they're important. All right, so anyway, we're going to start with what I think are the most important properties of an ellipse, things that will help you out when we're actually graphing them and actually talking about them. There's 7 things. 1, there are 2 axes of symmetry. It's an oval, right? You can fold it in half two ways, and it's symmetric. You need to make sure you know that. You don't have to write the exact things that I write, but know these things. There's lots of quote-unquote vocabulary in this section. There's 2 axes of symmetry, so they both have a name. The longer axis is called the major axis. Super fancy. And the shorter axis is called the minor axis. So I'm going to be flipping back and forth. I'm going to show you a picture so you know what I'm talking about, and then flip back to this, okay? So don't freak out. So in this picture, we have an ellipse. Ta-da! We have to decide each time what the orientation is. There are horizontal ellipses and vertical ellipses. It all depends on which axis is longer, right? In this case, the axis that's longer is horizontal, right? It's wider horizontally. So this is the major axis, and then this would be the minor axis. Does that make sense? Everyone with me? Okay. There are 4 vertices, the endpoints of each axis. It's the topmost point, the bottommost point, the leftmost point, and the rightmost point each time. So there are 4 vertices. When we're graphing these, you'll need to be able to graph the 4 vertices in order to graph the ellipse. Again, I'll come back to this. So 4 vertices. 2 at the ends of the major axis, 2 at the ends of the minor axis that the ellipse goes through. Okay? Yeah? All right. Some more vocabulary. This is important because we have to use them in our equations. The semi-major axis, which we call A, is the distance from the center of the ellipse to a vertex on the major axis. So it's half of the major axis. So really, it's like the radius of the major axis. We just don't use the word radius because that would mean that it's the same all the way around. Right? But it's like the half of that axis. Similarly, the semi-minor axis, which is B, is the distance from the center of the ellipse to a vertex on the minor axis. So it's half of the minor axis. Again, showing you a picture. So we know that from A to D is the major axis. Well, A is half of that. Just making sure we're following. We know that E is the minor axis. Well, B is half of that. Okay, so semi-major, semi-minor. Everyone good with that? Yeah? Maybe. Okay. We have one more thing. Remember there was those 2 fixed points that we're probably not going to graph a whole lot, but they're important to the whole definition of the ellipse. So there's a focus point, and there's 2 of them. So the plural of a focus point is foci. That's why we call them foci. So each focus is on the major axis. That's important. And then C is the distance from the center to a focus. We need to know what C is as well, probably. So again, the foci are inside the ellipse, and C is the distance from the center to one of those points. Okay? Does anyone need more time writing any of these things down? That's fine. There's just lots of little parts. I've got to make sure we know what they all are before I start talking about them. Are we good? All right. If you flip that note sheet over, it has the grid pretty much from your textbook. We're just going to copy into. So you have it for your notes. You have to use your textbook all the time. I will let you know what is on the red sheet and what is not. Okay? All right. We have 2 different things because we have horizontal ellipses and we have vertical ellipses. So it's important you know which one's which. So we have horizontal ellipses. We'll focus on those first. And before you start frantically writing a bunch of stuff down, I want to make a point. Okay? So if you look at the equation for a horizontal ellipse, okay? And I look at an equation for a circle. So I'm going to write a random equation for a circle. So some circle, let's say it was x minus 2 squared plus y minus 4 squared equals 16. Okay, that's a circle, right? A circle is just a special kind of ellipse. So I could put it into this format. If I divided everything by 16, right, I would have x minus 2 squared over 16 plus y minus 4 squared over 16 equals 1, right? Yeah? So just be aware that a circle is just a special type of ellipse. It's not a big deal. Some of the homework questions end up being circles. They're just written in this format instead of what you were used to in the last section. Okay? Anyway, all right. So you need to fill out stuff in the notes. I'm highlighting what is on the red formula sheet. You don't have to draw anything if you don't want to. You will have to know what's in purple on your own, not on the red formula sheet. I can talk about an easy way to figure that out. So you still have a center at HK, just like a circle. Still the same thing. We just talked about A, B, and C, right? So A is the distance from the center to a vertex on the major axis, and B is from the center to a vertex on the minor axis. We know what A and B are. We normally don't know what C is, so they give us an equation. C squared equals A squared minus B squared. That is not the Pythagorean theorem, so be careful. I just have seen too many people put a plus sign there by accident. Since the ellipse is horizontal, the foci have to be on that horizontal axis. That's why you have h plus or minus c comma k. You're changing that x coordinate. All right? That's how you remember how to do the vertices. The major axis vertices are on the major axis. They're horizontal. So because you added c here, you would add a to h to find the major vertices. So it's on the same axis. Okay, that's how you would remember that. It's a good note to make. All right, and then the minor axis vertices are the opposite. You're changing the y coordinate. So you're adding to the k instead of h. Okay? Everyone have the stuff written down for horizontal one. Yeah? Okay. Well, we also have vertical ellipses that have very similar information. Again, the stuff I'm highlighting is the things that they tell you on the formula sheet. When you get done writing this stuff down, we're going to talk about how you're supposed to tell the difference between the two if you're just looking at an equation. Sorry. Everyone have the stuff from the chart written down that they wanted to have written down? All right. I made two examples because we need to be able to tell from an equation if the ellipse is horizontal or vertical. One of these is horizontal and one of them is vertical. So when you're looking at your chart, you see how they wrote them very nicely for you where X was in the front for the horizontal ones and Y was in the front for the vertical ones? But there's a plus sign in between, so those fractions are interchangeable. So a lot of the time they aren't written with the Y in the front. So that is not how you get to tell if the one's horizontal or vertical, okay? Generally they're going to have X first and then they'll have Y. So you need to be able to tell how one's horizontal, which one's vertical. This is how. Whichever variable has the larger denominator tells the direction. If X has the larger denominator, then it's horizontal. If Y has a larger denominator, then it's vertical. So if you want to think about it, A squared is always going to be greater than B squared. If your larger denominator is under X, it's horizontal, right? Because X-axis is horizontal. If the larger denominator is under Y, then it's vertical. That's right. Y-axis is vertical. So the equation on the left, is that one horizontal or vertical that I wrote up here? Horizontal, and the one on the right is vertical. Does that make sense? Yes. Okay. So just keep that in mind, because again, they're not going to be written to where you're just like, oh, Y's in the front, that's it. That's not how we do it. Okay? So today I'm going to do Learning Target 6. Learning Target 6 gives you a graph of an ellipse, and you write the equation for it, which means you need to know the center, I need to know A, and you need to know B. Okay? Then we're going to do the first part of Learning Target 7, where they give you an equation in standard form, and then you find all of the information so that you could graph it. What is the center? What are the vertices? Okay? And then tomorrow I'll finish up Learning Target 7. I know I'm putting all of this together. All right, so Learning Target 6. We have a graph of an ellipse, and we're supposed to write the equation for it. And then we're going to find the coordinates of the foci, but we'll do that later. The first thing, every time you do any of these problems, you need to know if it's horizontal or vertical, because that makes a difference in how you write the equation. Okay, so is this ellipse horizontal or vertical? Vertical, right? It's longer going vertically, so it's vertical. So make sure you know that so you put it in the right format. From your formulas, you have that the equation should be y minus k squared over a squared plus x minus h squared over b squared equals 1. Right? That's from your notes you just took. So I need to know three things in order to write this equation. I need to know the center. I need to know what A is, and I need to know what B is. If I know those three pieces of information, then I can fill in the equation. I should be able to figure out all of those things from this graph. I will caution you, this graph, all of the boxes are 2 units. So make sure you're careful with your counting. Okay? So, first thing, we need to find the center. Right, the center is going to be where the two axes cross. So there's one axis between these two vertices and one axis between these two vertices. So the center is going to be right here. So I need to know what that point is. This is the origin right here. So what is that point? -7, 0. Question is what where -7, 0 came from. All right. A is the distance from the center to one of the vertices on the major axis. So again, the major axis in this case is the vertical one. And so A is going to be this distance. So that is 6. B is the distance from the center to a vertex on the minor axis. So that's this distance. Almost. 3. Very tricky, the graph. Okay, sorry, that's 2 units. I'm going to pick the example that has like counting things that could be messed up instead of a basic. Sorry. All right, if we have all this information, we can plug it into the equation. So I have, be careful with h and k. K always goes with y and h always goes with x. Just be careful. Y minus 0 squared plus x minus negative 7 squared. This is over 6 squared, and this one's over 3 squared, and that equals 1. And then you probably want to make it nice and neat. So y squared over 36 plus x plus 7 squared over 9 equals 1. That's the equation. Does that make sense to everybody? So we wrote the equation, and it says find the coordinates of its foci. So you have on your notes the coordinates for the foci are h, k plus or minus c. Well, I know h and k. Do I know c? Not currently. But I have a formula to find it. I also have the formula on your notes that c squared equals a squared minus b squared. Well, I know a and b, so I should be able to figure out what c is. Okay? So we fill that out. C squared equals 36 minus 9, right? 6 squared minus 3 squared. So c squared equals 27. And c is the square root of 27, or 3 squared root of 3. I really don't care which version you have, as long as it's not a decimal. Questions about how I found c? All right, then we actually have to write the coordinate. So we have h, which was negative 7, and then k, which was 0, plus or minus the square root of 27. You can leave it in this format. That's totally fine. Or you can write them individually. Both are acceptable. So if you wrote them individually, we would have negative 7 positive square root of 27 because you have 0 plus. And then the second would be negative 7 minus the square root of 27 because it's 0 minus. But again, you can just leave it just like this, and that'd be okay. Because you're not going to graph them at any point. Questions about any of this example? That's learning target 6. Not so bad. All right. So now we're going to do one example from learning target 7 for the first part. All right, learning target 7 says that you should be able to take an equation in standard form, and then you should be able to find all the information from it and graph it. All right, I'm going to do this example today. You can do the other one later if you would like to, but I'm going to do the second example. All right, so it says for each equation, we need to find the coordinates of the center, to find the foci and the vertices, and then we're going to graph it. So let's find the center first, because that's the easiest part. What is the center of this equation? 0, 4. Is this equation representing a horizontal or a vertical ellipse? Horizontal, because 81 is bigger than 49, and the 81 is under the x. Okay, let's worry about the vertices then next. Okay, you have major vertices and you have minor vertices. You can use your notes for now. Again, they're not on the red sheet though, so be careful. So it's horizontal, and so it's horizontal. That means I'm adding to, for the major vertices, I'm adding or I'm changing the x distances. So I'm going to be changing, going with h. So we have the equation h plus or minus a comma k. That's from your notes. I didn't make that up. I don't think. We know h and k already. And then we actually do know a. In the equation, this is a squared and this is b squared. So if a squared is 81, what is a? 9. All right, so I can fill this in. I've got 0 plus or minus 9, comma 4. These are generally going to be integer values, so I would like you to write these separately, because normally you're not going to have 0 plus or minus something. You'll have an actual number plus or minus something. So we have 2 points, positive 9, 4, and 1 at negative 9, 4. Questions about where those came from? We need to do the same thing for the minor axis vertices. Looking up for your notes, you have h and you have k plus or minus b. You're changing the y distance. So again, we have h and k, and we do actually know b. If b squared is 49, what is b? 7. So we have 0, 4 plus or minus 7. And see, in this case, it would be a perfect example of when you want to make sure you write 2 points, because we know what 4 plus 7 is and what 4 minus 7 is. So what's 4 plus 7? 11. And what is 4 minus 7? Negative 3. All right, those are the things you have to have in order to graph it. So we're going to graph this quickly. Oh, this is from earlier. All right, so we have, I'm going to move this up here so I can see it. Our center's at 0, 4. So that's right there. We have major axis vertices at 9, 4, which is right here, and negative 9, 4, which is right here. We have minor axis vertices at 0, 11, which happens to be right there. Sorry, right off the graph. And then 0, negative 3. And then you do the best you can to draw an oval, and that's why I'm cheating. Oh, it's not really a good oval. I'll probably freehand it better than that. Dang it. It's not going to be tall enough. How disappointing. I'll freehand it, and it's going to look terrible. So bad. So bad. So bad. The only other thing it asks on this question is to find the foci, which again, we don't have to graph, but we can still find them. So to finish out the question, it says to find the 2 foci. Again, from your notes, that's h plus or minus c comma k. We don't know c right off the bat, but we have an equation. C squared equals a squared minus b squared. A squared was 81 up here, and b squared was 49, so we have those. So c squared equals 81 minus 49. So c squared is 32. So c is the square root of 32. I'm going to leave it that way for now. You can simplify it if you want to. I'm just trying to save time. And then I go back and I write my 2 coordinates. So h was 0 plus or minus the square root of 32, comma 4. You don't have to graph them. We just have to list them as part of the problem. Questions about that, though? I know about the pieces, but I don't think that it's, like, atrocious in difficulty. Okay.